Swayam Prabha. Digital India. Educated India.
Welcome to the NPTEL course on building energy systems and auditing. The module 3 is going on, and this module 3 is basically on the building heat load estimation. In the lecture number 12, we will discuss the cooling degree days method. So, in this method, in this particular discussion, we will cover up the cooling degree days, the concept of the cooling degree days, and we will discuss stepwise, we will give the demonstration on how through the cooling degree days the building load, cooling load can be estimated. Now, first of all, we need to know the what is cooling degree days and what is heating degree days. So, you know this particular the temperature, outdoor temperature of a particular area is always a kind of a follow a periodicity in kind of a nature. So, it increases and then somewhere after some time it decreases or so, and it create a kind of a similar pattern for if you take a kind of a some portion of the 3, 4, 5, 6 days. But maybe there is a slight difference after certain some changes in the weather condition and all, and also during the change of the season from summer month to the autumn, from autumn to the winter month, there will be slight changes and gradually that particular periodicity will going to change, but the amplitude is going to change. There may be a kind of the it will maybe high peak will go down or whatever, but again if you take a particular patch of maybe 15 days to 1 month or maybe 7 days, 18 days or something like that, it will remain almost like a same if there is no such of sudden change of weather or so. So, in this particular behavioral pattern of the outdoor temperature, we can think of a mean temperature and the base temperature, and based on that we can calculate the total heating load. We may not go into deep into detail of each hour the outdoor temperature, or maybe the daily peak and daily the changes in the after some 6 hours or so. So, only a diurnal temperature difference we can think of, and then we can find out the what is the average temperature difference, and if there is some kind of a base temperature, we can see the deviation and we can think of that. I mean we can assume that that particular the shift, that particular distance between the mean and the base temperature is my the cooling or heating the requirement, that much degree centigrade is my heating requirement or so. So, in this kind of the periodicity when it is available, so we can actually get some weather data or the kind of the temperature data at least for a kind of any city, maybe a monthly average or maybe a daily average, something like that, and we can actually go to a calculation mode to see that per month how much is the degree days, how much is the these deviations also. So, to explain that particular thing, let us take 1 day temperature data. Suppose this is a particular day temperature data, it is night 12, it was midnight, it is 18 degree, and then gradually it is increasing, and finally, it is increasing to 36 degree at around 3 p.m. in the afternoon time, again it is decreasing to 18 degree to the night. So, the periodicity, the behavior or the change and ups and downs of this temperature profile will be like this blue color dot joining the dotted points or so. Now, I may think of a baseline, something like what is base temperature or the baseline. I want to keep the room 20 degree centigrade temperature, that is my base temperature of a particular room. I want to I want to keep the room as 20 degree centigrade temperature. In this way, I may say that this is the difference between the this base temperature and the outdoor temperature. So, at the midnight the base temperature is I want to keep it 20 degree, but outdoor temperature is 18 degrees. So, it is -2. So, I do not need any kind of cooling. I do not want to switch on the air conditioner at that particular time, because I am already in 20 degree temperature, which is comfortable temperature for me. Outdoor temperature is 18 degrees centigrade. So, those minus are in the blue color. So, I do not need any kind of the heating any kind of cooling requirement on those times, maybe from night 12 to almost morning 6 o'clock. I do not need any kind of, but morning 7 I need 1 degree temperature cooling, morning 8 o'clock I need a 2 degree temperature cooling, because the outdoor temperature is 22 degree at 8 o'clock in the morning and my base temperature is 20 degree. Of course, I have, or this particular method has assumed that it is a very quick and very steady state flow, but it will not be, because there is a wall we have discussed in the very first lecture, there is a discriminant factor, there is a time lag. We will discuss this one in this lecture also, not in this lecture, but the subsequent lecture of this module itself in the last, that how this discriminant factor will take place or will affect it. But here at present for the cooling degree days, let us assume that it is instantaneous steady state flow. So, that way you see the maximum demand is almost 16 degree at around 15 hours, that means 3 p.m. or so. So, that means I may say that this particular area which is above the base temperature is required cooling, this particular required cooling, and that much of temperature has to be brought down to the base temperature. So, I think morning 7 o'clock 1 degree temperature has to be brought down, 8 o'clock 2 degree temperature has to be brought down. Similarly, at 12 noon almost 11 degree temperature has to be brought down, like that we have to brought down. So, total summation of the brought down has to be the sum of this particular the hill like portions, the above the base temperature 20 degree, that portion. Now, what we can do, we can further rectify it such a way that we can actually pick up the minimum temperature and the maximum temperature of the day. That means, the T minimum and the T maximum of that particular day. T minimum is 12 degree and T maximum is 36 degree. So, I can find out the daily mean temperature, that is half of the T maximum and the T minimum, because for weather data it is easy to get the T maximum and T minimum. Lot of website is giving you, lot of newspaper sometimes gives you, or there are lot of sources that for any kind of any city you can find out the T maximum and the T minimum for day or maybe for that particular month or whatever. So, in this case my daily mean temperature T mean is 24 degree, 36 plus 12 divided by 2, and my base temperature. So, this is the T mean and my base temperature is 20 degree. So, base temperature is, this is T, this is base temperature is 20 degree, T is periodicity, T base is a fixed, T mean is also fixed based on this 2, this 12 and 36, this 24 has been computed. Now, there is a difference of 4 degree between the T mean and the T base 20 and this 24, that is going to be a significant for our CDD, that is cooling degree days. So, total how much is the summation of the T mean and T base? It is 4 into 24, because there are 24 hours and there are 4 degree difference for this particular T mean and T base. The sum of the T mean and T base is 96 degree. So, that means I can say this hum is almost like 96 degree centigrade, this hum. So, you require a 96 degree centigrade of the cooling for your day if you take all the highest number or so. Of course, it is not exactly, because there is a approximation of T mean and T base, it is very close to the 96 degree. So, this way I can understand that there is a I can actually from the weather data I can actually convert that to the per day how much degree of the temperature I need to go for the cooling. And if I know the OHGC or this the overall heat gain coefficient, so I can actually multiply that and I can find out the daily the cooling load or whatever may be that. So, this blue portion, this 4 degrees the drop, and the summation of that is your 96 degree total for that particular day. So, what happened is that this particular hump above the T mean, I am sorry, above the T base, which is 20 degree T base, is now neutralized, and we now we think of it is constant for whole the day, and that is actually your cooling degree day of your 2 degrees or so. For your base temperature is 20 degree. I am sorry, this has to be 4 degree, we have discussed that one, this is a typological error. So, I will rectify this, this will be the 4 degree, that we have 4 degree, and with the 24 hours is 96 degrees or so. So, this 4 degree is average, I may say that for the whole the day is the total degree of my cooling requirement. Now, suppose this is the temperature data of Delhi. So, I have just picked up the, so it is the minimum and the maximum temperature from January to December. So, I picked up the data of January, March and May. You see the January Delhi is 20 degree maximum and minimum is 8 degree, this is 20 degree maximum January, the maximum temperature is 20 degree and minimum temperature is 7.7, that is 8 degree, I kept it 8 degree. So, mean temperature is 14 degree, 20 plus 8 by 2, 28 by 2, 14, and I kept as base temperature as 20 degree. So, 20 degree is my indoor base temperature, I want to keep that. So, it is negative in the Delhi month of January. That means, in month of January I will not need any kind of the cool. So, any negative I will not going to take, I will take only the positive values, because that is my cooling demand. Negative I do not need any kind of a cooling, it is already cold. In the March, what is the temperature? T max, March, T max, March is here, T max is 15, I am sorry, this Fahrenheit. So, minimum temperature is 15.2, so 15 I think I kept 15 and maximum is 29, so it is 30. So, that mean temperature is 22.5. So, there is a 2.5 degree is the difference between the mean temperature and the base temperature. That means, 2.5 degree per day, and I am actually calculating for the month. So, the March has how many days? March has 31 days. So, 31 into 2.5, that much amount of cooling load is required, degree cooling load is required for the month of March. In the month of May, it is almost 40 degree and the minimum is 25 degree. So, the 32.5 degree is the min and 20 is my base. So, 12.5 degree is the per day for the whole month of May is the cooling demand. So, I have to multiply with the number of days, May is 30 days. So, 30 into 12.5. So, now how can I further rectify it, this cooling degree days? So, CDD is negative for the month of January. So, no cooling is required, fine. The average daily CDD is 2.5 degree for the month of March. Okay. So, if the building is running all 30 days and 24 hours per day, suppose it is a hospital building where every 24 hours you need cooling. So, 2.5 degree per day, 30 days in a month and 24 hours. So, almost about all the three, if you multiply, 1800 degree cooling is required for whole month for that particular building or that particular space. If the building is running 24 days only, suppose that building, in some office building there is 6 days of holidays and 8 hours per day, because it is a kind of office building. So, your total multiplication of 2.5, 24 is the number of days and 8 is the number of hours per day. So, total about 460 degree cooling is required for the month of March for some other building which is running 24 days and 8 hours per day or so, right. So, similarly, if I take now the month of May, your CDD is 12.5 degree. per day, it is the average of course for the month, but what I can assume that for the month of March 22.5 degree is the average difference between my T mean and the T base. I have kept my T base as 20 degree because of that. Now, if I keep the T base is 22 degree, this will be now 2 degree less, so maybe 10.5 degrees or so. So, similarly, if I have a 30 days of 28 hours, so you see the month of May, you need to have 9000 degree of cooling load requirement, because the month of May is much hotter than the month of March. Second type of building, 24 days with the 8 hours, you multiply 12.5, 24 and 8. So, 2400 hour degree of degree centigrade will be the cooling requirement. So, now we can really understand that because of the change of the month, due to the change of the maximum temperature and minimum temperature, my T mean is going to change, and my base temperature if I fix, and then if it is not negative, if it is positive, this difference between the T mean and the T base, that means I require some kind of a cooling, that much degree of cooling is required for that particular month. And now that particular month, how many days working day, how many hours of working per day, if I multiply that, I can actually estimate that how much degree centigrade will be the total cooling required for that building for that particular month. And now if I multiply with the overall heat gain coefficient, which is the multiplication of the envelope area, corresponding envelope area to the U value, I can directly find out how much is the cooling requirement or so in kilowatt hour or so. So, here this is the formula I have already discussed. Here there is a plus sign means I will always going to take plus, because negative sign I will not going to take, because negative sign, why should I take negative sign? If this T mean minus T base is negative, then it is a cooling, no cooling required, that we have seen in the Delhi case in the month of January. So, and this is the finally this overall heat gain coefficient will be multiplied with the CDD with 24 or whatever the number of days or whatever, and number of hours and whatever is that, and then we have to divide this 1000 to just convert that from watt to kilowatt or whatever that way. So, now let us see this discussion on this particular building. This building I have kept, I have drawn the two floor plans of a building, the ground floor and the first floor. This hatched portion, green hatched portion is the air conditioned area. So, I do not need any kind of air conditioning cooling load calculation for those areas. So, only these areas has to be calculated. So, WWR for the north and south facade is 20%, and the WWR for the east and west facade are 15%. So, there are little less amount of the windows in the west and the east, and the U values are given to you. So, first of all what we have to do is we have to first find out the each facade area and also the roof area. So, now suppose if I want to find out the area of the north. So, this wall is on the north, and also in the first floor this wall is in the north. So, this wall area will be, this is your 10 meter multiplied by the height of the floor. Height of the floor is taken as 4 meter, 10 into 4 equal to 40, and this is also north. This north is your 15 meter into 4 meter is equal to your 60. So, 60 plus 40 will be your 100 will be your north area. So, like that I can calculate the south area, you can calculate the east area and the west area also, and also the roof area. The roof area will be the roof of only the first floor, I am sorry, only the first floor this area, and maybe some remaining portion of this particular area also can be taken. So, roof area is also these 3 patches of the first floor. I am not I should take this one. The roof area will be I have to take the first floor. So, it is 15 into 4 is your equal to 60, plus this is 15 into 4, this one, and this is 8 into 4, 32. So, that means 92 will be the roof area. So, I have calculated, and this is that particular city, the T max and T mean has been given for all the month, and I have assumed the base temperature as 22 degrees C. That will help me to find out the CDD, and 20 days a month, 8 hours working day. So, we will take that afterwards. Let me first find out how to calculate the areas and all. So, this is the, if you see the area, north facade area, I have just told you it is 100. Then the east facade is this and east facade is this. So, this is 4 into 4. Please remember the height is 4 meter, the floor height is 4 meter. So, 4 into 4 again. Okay. This I cannot take because this is some area which is having some kind of a space. So, this is not exposed to the wall, exposed to the outside. So, east is your 32, 16 plus 16, 32, 15%. So, I can find out the total wall area and the window area. This is the wall area and the window area. Similarly, the south is having this 2, these 2 are your 32, this is your 32 because 4 8 4s are, and this is also 32. So, it is almost about 3 times 32 is 96, 96 meter square, and then the WWR and all these things are there. So, from that I can find out the wall and this area. And finally, west is also same, west is this one is the west and this one is the west similar to the east. So, that is 32, and finally, the roof area is this chunk of the roof is 60 and this chunk of the roof is 32. So, 92. So, like that I have broadly taken all the area. I have 4 sides, I have roof also. So, I have taken all the area and I put it there in the Excel chart. I have another Excel chart for this. So, I will go to the Excel chart. So, this is that Excel. So, the facade 1, now I have kept 10 facade, maybe you can have different type of facade, maybe not only 4 sides. So, you may have 10 facade or so. So, from here I can give the areas like this is the north is 100, the east is 32 and this is 96. So, let me first give this is 100, this is east is 32, this is 96 I think, and this is again 32, and your roof is your 96 probably, the roof is your 92, sorry 92, roof is your 92, and WWR for the roof is 0 because there is no window, and this the facade, this is 20 and 15. So, this is your 20% is the facade 1 and facade 3, sorry 20% is facade 3 and this is 15% and 15%. So, and this is the U value of the wall, U value of the window. So, you will get, and this is your T max and T min, best temperature is 22 degree, working days of 20 degree, 8 hours of working days, that particular thing, and this is your per month what is your heat load calculated, that is estimated in this through this Excel chart. So, here again let me go back to the slide. So, here you see this overall heat gain coefficient which is equal to your So, that is equal to your summation of A into U. So, that means summation of A and the U. So, for windows and for there are different U values, the different U values for the window, different U values for the wall. So, if you just A U of the wall is this much, A U of the windows is this much, and if you add up 3992 is your OHGC. Now, here you see I have calculated the mean temperature and the base temperature. So, January mean is 20, the base is 22, CDD is 0, actually it is -2. So, no heating is required. So, 0. Even February it is 22, 22, 0, even December it is 20.5 and 22 it is 0 because it is negative. So, I may say that in the month of March only 2 degree of heating required per day, average per day. So, month of March has 20 days or whatever, of course, month of March has to 31 days, but the working days I am keeping as 20. So, 20 into 2 degree means 40 degree is per day, and there are 8 hours. So, there are 8 into that. So, 8 the 40 into 8. So, the 320 degree is the total cooling requirement of the month of March. So, this will be your 2 into 20 days into 8 hours. So, almost 320 degree for the month of March, just like we have seen in the earlier example of Delhi. Similarly, for the some month of maybe June, it is 11 degrees. So, 11 into 20 into 8. So, something like that, some big value, some big value will come, and then that has to be added. So, here I have did that one. So, this is the CDD what I have got it from here, from 0 0 2 7 11 11 11 0 0 2 7 11 11. This is the, and this is the 20 days. This is the CDD per month. So, just multiply 20 into 2, 7 into 20 140, 11 into 20 220. This is the your OHGC, multiply that with the working hours 8. So, total that much kilowatt hour will be my total requirement. Now, let me see the balance of unit balance, because unit balance always I love to do. See, OHGC is what? It is the A into U. So, the meter square into watt per meter square degree C. Okay. So, this is gone. So, the overall heat gain coefficient has a unit of watt per degree C. Now, this is rest of all CDD is degree C multiplied by this 20 number of days, number of hours. So, number of days 20 gives a kind of a degree C, because that 20 days 2 degree. So, total your 40 degree. So, this is actually going to be some degree, and this is days, this is hours. So, what I am doing over here, so if I write here, this is OHGC, I am multiplying with CDD per month and multiplying by hour. So, OHGC is your watt per degree C multiplied by the degree C into hour. So, that means I am finally getting watt into hour, and I am converting that to kilowatt hour, which is the unit of energy. So, I have got, and then if I sum it up, so finally I got 40,878 watt hour. This is in watt hour. This is in watt hour. This is in watt hour, and so, and I can find out that one in, I think I have divided that into the kilo 1000. So, it is watt hour, or maybe the kilowatt hour. I have to, I think it is kilowatt hour, and then I can check that one. The total amount of 40,878 kilowatt hour is the total requirement of the cooling load for that building annually, annual cooling load requirement. If you remember the last class what we did, last lecture what we did, we actually calculated for a particular solar radiation and temperature for a particular time, for that particular hour or whatever, and now it is whole soul for a year, but of course, it is approximate. It gives you only the conductive kind of a treatment. It is not taking care of your radiation heat, because SHGC is missing, solar air temperature is missing, no data of the solar radiation is there. We will see that also will come in the later, we will of course see. So, but if you want to see some kind of a comparative study of two different building in the same locality, or maybe a same building in different locality, just to change of the CD. So, we can have a kind of idea that what could have been my annual cooling load, what could have been my total amount of the cooling load requirement, or my expenditure for electricity for running the AC, the air condition and all these things in a building. So, that is why if I again go back to the very first this figure, I am not have not taken the all the portion of the building, the white portion I have not taken, the white portion, the surface area of the white portion I have not included in my calculation, because by virtue of the architectural drawing I know the ground floor these 3 patches, and in the first floor these two patches will be the air condition. The rest white areas are non-air conditioned area, that means maybe some store room, some canteen, maybe something like that, some toilets, maybe some staircase or something like that. So, and the central blue patch is the corridor. So, I only take care of the air conditioned area, and not only air conditioned area, I have taken care of the air conditioned surface area of the air conditioned area, and then I have calculated. So, based on this calculation, I have demonstrated that one to you. So, first you have to give the facade area of different facade. I have kept 10 facade area, and maybe your building is too large, or maybe some kind of there is not only always square or rectangular shape, there may be typical shapes. So, you may have different the areas. So, you may have require 10 areas, you may then you give the monthly maximum and minimum temperature of the location. You can generate it, you can get it from some kind of the website. I have mentioned one website here. If you can go to this particular slide, this www.degreedays.net. So, you can check that one, you can get the directly the cooling load and all. So, and then the base temperature and the working hours, day, etc. If you can feed your this thing will be ready. So, this is the what we have shown to you. And so, if I again let me before finish, if I go back to the Excel chart. So, you see this is the case we have discussed. You are getting this 3992 as a OHGC. Now, what is the total amount of cooling degree days? 12,8 1280. Annual cooling energy demand is 40,878 kilowatt hour, and peak monthly demand is 7,025 kilowatt hour. That is for this 3 month, because this 3 month you see this is having the same the temperature, or the T max and T mean is such a way that your average temperature are same. Now, if I change the base temperature, suppose I am not comfortable with 22 degree, I am comfortable with 18 degree, that particular building, that the area I am not going to change, that particular 18 degree. You check this value, the peak is 7,000 and annual is 40,000. If you make it like change, it is now changing, it is 9,000 is the 9,500 is the peak instead of the 40,000, now it is 69,000 is the peak. Only change of how much? 2 degree. The last one is 20, I think, no 22, there is a 4 degree change. The 4 degree change, there is a change of that much. So, if you think of that I am comfortable with 24 degree, 2 degree up. So, instead of 40 it will be less than 40, now it is 30, almost 10,000 kilowatt hour decrease. 10,000 kilowatt hour decrease means if you take 7 rupees per kilowatt hour as electricity charges, almost 70,000 rupees decrease for annually your electricity bill. And you see now we are getting 3 month as and November also 0, November, December and January, February month you do not require any kind of a cooling, because those are your increases the base temperature. So, 22 degree, let us keep 22 degree, and your monthly days if you increase, or maybe your working days instead of the 8, if you just go for 10, it is increasing from 40 to 51. So, and now if you just change the facade area, suppose you want more facade area as to be the air conditioned more area, instead of this white patch area you are going to more area, suppose it is 120s or so, it is changing, it is maybe some other facade area is 130 or so, it is changing, it is increasing. So, by virtue of any change in the facade area, by virtue of any change in the any days, number of working hours, number of days, if you change to the, suppose it is a fully the 30 days building like hospital and 24 hours building like hospital. So, you see it is 1,83,000 coming up the demand, annual demand, almost 1,40,000 is the demand. So, it is interactive chart I have prepared for you, I will share it to the in our forum and for you, and let me finish the lecture. So, this is the some of the references, and whatever we have discussed is that the heating or cooling degree days is the amount of heating required or cooling required average throughout a month or throughout a time period, maybe in a day, that is first being calculated based on the mean temperature and the fixed base temperature, and based on that with the overall heat gain coefficient, the heat load is mapped or calculated. Thank you very much.